Okay, so let's talk about Unit 3, Part 2, Solutions, Mixtures, etc. So, enduring understandings, interactions between intermolecular forces influence the solubility and separation of mixtures. There is some word that there may be a lot of experimental type questions looking at data because that's less easily Googled. I don't know how true that will be. In fact, no one knows. So, when we are trying to separate substances, it depends on what things are mixed together, how difficult it is to separate. If we have a solid with a liquid solution, then we can use filtration. And I would go through and see all of the types of separation mechanisms available. If we were separating two liquids that are mixed together and they have different boiling points, we can use distillation. We can also identify that we have two liquids present by using liquid chromatography. We can also do selective precipitation where we have a solution, say we have some sodium chloride and we have some silver nitrate. If I add that sodium chloride to silver nitrate, the silver will precipitate out as silver chloride. I can then collect that solid and dry it and then weigh it and figure out how much silver chloride I have, and then using stoichiometry go back and see how much silver nitrate was in the original solution. So you should also know how to calculate molarities. That's about the only concentration unit we have. We also do percent, but that's usually with solids, not with aqueous solutions. You should be able to use particulate drawings and represent those. Colligative properties are not assessed, and molality, percent by mass, etc. is no longer assessed on this exam. We did have a particulate drawing on one of the review questions that you had earlier this last week, so if you had trouble with that, I can go over it with you again. You should be able to explain the relationship between solubility of ionic and molecular compounds. It is not simply enough to say like dissolves like. You have to explain that water is a polar solvent. It has a dipole moment, so it can dissolve things like ionic compounds, silver chloride, or not silver chloride, sodium chloride, and how you would separate them. Chromatography, TLC, thin layer chromatography, separates compounds because one of them will have an attractive force for the paper and one of them will have an attractive force with the solvent, and so you can separate the two. I think we did that with markers. If not, we can maybe do a home lab. Distillation separates them based on boiling points. Explain the relationship between the solubility of ionic and molecular compounds in aqueous and non-aqueous solvents. So something like carbon tetrachloride is a nonpolar solvent, so it would dissolve nonpolar things better. So hexanes, which is just carbon and hydrogen, anything that ends in A and E is just carbon and hydrogen, would dissolve in something like carbon tetrachloride, whereas it would not dissolve in, say, water, for example. And that's why water and oil don't mix, is because one is a hydrocarbon and one is not. Spectroscopy. Spectroscopy uses emission spectrum when we look through our scopes at the lights overhead and saw the line distribution of the various elements in like the mercury vapor light. We also looked at the elements and saw things like xenon and neon and had the discrete lines. You should be able to calculate then from their wavelength what their frequency is, also what their energy is. You have equations for that. Some of this I don't think will be tested just because it's too difficult to test and too easy to Google. So I think you should understand the process that electrons, when subjected to an emission or are hit with incident light, then they absorb that energy to promote an electron to a higher energy level, and then they drop back down, and then they emit that energy in the form of light. And those light frequencies are discrete, meaning that it's a particular wavelength that is not continuous like a rainbow. So, you should be able to calculate, and here we've got the energy in C equals lambda nu, and E equals h nu. Those calculations are pretty straightforward. I am concerned that we will not have a lot of straight out calculations on this exam because that is too easy to cheat with. And so we may have more explanation. I assume they'll have you calculate something, but then explain why the energy between two different lines is different or something along that way. Comparing and contrasting, justify, those kinds of things. The structure of the atom can be determined with certain types of spectroscopy. One thing that we did was the absorbance, where we took a solution, we diluted it, and we created a calibration curve using Beer's law, or Beer-Lambert law, which says that the absorbance is directly proportional to the concentration. E is the absorptivity, B is the path length, and C is the concentration. And so we can actually get, we can identify the concentration of an unknown based on having a calibration curve. So I will come back with the last 3 units each and individually. Thanks.